The purpose of this video is to go over the review for test unit 1 on equations. It's a review sheet that looks like this. It does have the answers on the back, but if you're struggling with one of the questions, hopefully this video will help. We're going to go through each question one at a time, and if you want to rewind the video to take a look and see how these questions were figured out, you can do that as many times as you want. But these are also the same type of questions that you will see on your test coming up in a day or two. So here's number 1. We're going to start number 1 by using the distributive property. I'm going to take 3 times 5x, which is 15x. 3 times negative 4 is negative 12. And then whenever we have a set of parentheses with a negative sign in front of it, it's like there's a negative 1 in front of it. So this is like negative 1 times 4x, which is negative 4x. And negative 1 times negative 7, which is positive 7. And then I can combine like terms. They're on the same side of the equation. There isn't no equal sign, so it's not like I'm going to add 4x to both sides. I'm simply going to take 15x minus 4x, which is 11x, and a negative 12 plus 7 is negative 5. So number 1 is 11x minus 5. Let's take a look at number 2. Number 2, we have a fraction that we're going to be distributing times over a set of parentheses. And the way we talked about doing this in class, one shortcut way of doing this is to always multiply by the top and divide by the bottom. So we could take 12 times 2, which is 24. 24 divided by 3 is 8x. And then if I take 2/3 times negative 9, I could take negative 9 times 2, which is 18. And 18 divided by 3 is negative 6. And so number 2 simplifies to 8x minus 6. Let's move on to number 3. Number 3 is 5x plus, and then we have 3 times 2x minus 3 minus 12. And so I'm going to start this one by using the distributive property. We'll have 5x plus 3 times 2x is 6x, and 3 times negative 3 is negative 9 minus 12. And then I'm going to add like terms. 5x plus 6x is 11x, and a negative 9 and a negative 12 is negative 21. So we have 11x minus 21. We take a look at number 4. Actually, we'll do 4 and 5 here. Number 4, we're supposed to be sure to put an expression in the correct order and to use parentheses when needed when we convert something to from English into algebra. So number 4, twice the sum of a number in 8. Well, here's the sum of a number in 8. I want twice that, so I am going to multiply it by 2. So I will need the parentheses because I'm going to have to take the sum times 2. And then number 5, 5 less than 4 times a number. Well, here is 4 times a number, but I want 7 less than 4 times a number. I want 7 less than that, so it has to be minus 7. I can't go 7 minus 4n. It means something completely different. All right, moving on to numbers 6 through 13 are on solving equations. And so number 6, we have 3/5 x minus 3 equals 12. We're going to start to solve this equation by getting rid of what we're subtracting. We're subtracting 3, so I'm going to undo subtracting 3 by adding 3 to both sides. So the 3's would cancel. Negative 3 plus 3 is nothing. We have 3/5 x equals 12 plus 3 is 15. And I'm going to undo multiplying by 3/5 by multiplying by the reciprocal, which is 5/3. The 5's would cancel, the 3's would cancel, and we'd have x equals 15 times 5 divided by 3. 15 times 5 is 75, and then 75 divided by 3 is 25. So number 6, we have x equals 25. Let's take a look at number 7. Number 7 is 14 minus a number is 20. So I want to get n by itself, but I'm going to start getting rid of this 14, and 14 is a positive number. So I'm going to subtract 14 from both sides. And I'll have negative n equals 20 minus 14, which is 6. But negative n is like negative 1 times n. So I'm going to divide both sides by negative 1, and n is negative 6. let's take a look at number 8. Hopefully I'll be able to fit number 8 on this paper. Yeah. Number 8, a little bit longer. We have 2x plus, and then we have 3 times 2x minus 4 plus 16 equals 20. So we're going to solve this equation by first distributing the 3. So we'll have 2x plus 3 times 2x is 6x. 3 times negative 4 is negative 12, plus 16 equals 20. And then I can combine like terms. 2x plus 6x is 8x, and a negative 12 plus 16 is positive 4 equals 20. Then we could subtract 4 from both sides to get rid of adding 4, which means we'd have 8x equals 16. And then we want to divide both sides by 8 to get rid of the 8, and x would equal 2. So that is number 8. If we move on here and take a look at number 9. Number 9, we have a fraction. We're going to take 2/3 times 6x plus 15 equals x plus 1. So we're going to start this problem by distributing the 2/3. 2/3 times 6, again, I can multiply by the top and divide by the bottom. 6 times 2 is 12, and 12 divided by 3 is 4x. Plus 15 times 2 is 30, 30 divided by 3 is 10, equals x plus 1. Then we have x's on both sides of the equation. I would probably subtract an x from both sides of the equation. That way this would be gone, and I would have 4x minus x, which is 3x, plus 10 equals 1. And then we could subtract 10 from both sides. I want to get x by itself, so we're going to subtract 10 from both sides, and 3x will equal 1 minus 10, which is negative 9. If we divide both sides by 3, x is negative 3. If we go on to number 10, number 10 is 4 times x minus 3 plus 6 equals 2x plus 4. So if I distribute the 4, 4 times x is 4x, 4 times negative 3 is negative 12, plus 6 equals 2x plus 4. I can combine like terms here. I can't do anything with the 4x, but the negative 12 plus 6 is negative 6 equals 2x plus 4. And then I have x's on both sides, so I'm going to subtract 2x from both sides of the equation. So 2x minus 6 will equal 4. And now it's a two-step equation. I can add 6 to both sides, so 2x equals 10. And if I divide both sides by 2, x is 5. Let's move on to number 11. Number 11, we have x plus 2 over 8 is equal to 3x minus 1 over 10. And this is a proportion. We have two equal fractions. So whenever we have a proportion, the cross products are equal. One cross product is 8 times 3x minus 1. The other cross product is going to be 10 times x plus 2. So if I distribute here, 8 times 3x is 24x. 8 times negative 1 is negative 8. 10 times x is 10x. And 10 times 2 is 20. Now I have x's on both sides. I can subtract 10x from both sides. So 24x minus 10x is 14x minus 8 equals 20. And now we have a two-step equation. I could add 8 to both sides. So 14x equals 28. And if I divide both sides by 14, here the 14s will cancel out, and x equals 2. Number 12. Here's number 12. Number 12, we have hx minus w equals k. And we're supposed to solve this for x. We want to get x completely by itself here. So I need to get rid of the h, and I also need to get rid of subtracting w. I'm going to start by adding w to both sides, because a negative w plus a w those would be equal to 0, which means they cancel out on this side, and I have hx equals k plus w. And then I'm going to divide both sides by h. So x equals k plus w all over h. And that is number 12. If we take a look at number 13, same kind of question, 2/3 a times b times c equals d. And we want to solve this equation for c, which means we want to get c by itself. So I'm going to start by getting rid of multiplying by 2/3. And so to do that, I would multiply both sides by 3 over 2, the reciprocal. That way the 3's would cancel out, the 2's would cancel out, and I'd be left with a times b times c equals d times 3 over 2. Because I'm multiplying, and I could put d over 1. Well, then I still want to get c by itself, and I'm still multiplying by the a and the b, so I'm going to divide by a and b. That way the a's would cancel and the b's would cancel. But I'm also going to divide this side by a and b. So I will have c equals d times 3, or 3d over 2ab. And that equation is just rewritten so that c is by itself. Let's move on. Number 14 and number 15 are two special type of equations that we are going to want to know about when we solve these equations, because sometimes something special happens when we solve equations where we really don't get a single answer. So let's take a look at number 14 first. If I simplify the left side of the equation, I'm going to start by using the distributive property. I'll take 2 times 4x, which is 8x, and 2 times -7 is -14, plus 6. Equals, if I use the distributive side on the right-hand side of the equation, I'll have 8x minus 8. And so I could simplify here. A -14 and a +6 is a -8, equals 8x minus 8. Now, something weird happens if I add 8x to both sides. Actually, if I subtract 8x from both sides, 8x minus 8x cancels, and 8x minus 8x cancels, and I get -8 equals -8. Well, that's always equal. Because that's always equal, it doesn't matter what x is. There are an infinite number of solutions to this problem. No matter what I stick in for x here, and no matter if I stick in the same thing on this side, I will always end up with -8 equals -8, which means the left side of the equation will always be equal to the right side of the equation. And I have an infinite number of solutions. That is different in number 15. Because on number 15, we get something that they're never going to be equal to each other. Let me explain what we're doing here. We're going to simplify both the right side and the left side of the equation again. I'm going to take 3 times 2x, which is 6x. And 3 times 5 is 15. But then on the left-hand side of the equation, 2 times 2x is 4, or right-hand side of the equation, 2 times 2x is 4x, plus 2 times 1 is 2, plus 2x. And then I could add these like terms together. 4x plus 2x is 6x plus 2. Equals over on the left-hand side, 6x plus 15. And now if I subtract 6x from both sides, these x's cancel, and I get 15 equals 2. That's never going to be equal to each other, which means there's no way I can find a number that I can stick in to make the 15 equal to 2. There's simply no solution here. And so, number 15, there will be no solution. We move on then to number 16. 16, 17, 18, and 19 are all the story problems. And so they are on the back side of the page set up for you. But let's talk about how they get set up. Number 16, when starting a hair salon, Debbie paid $7,700. So one of the things that she paid for was, or she had a certain cost of, was $7,700. That was her cost. But it also says that it also cost her $3 per customer for a haircut. So that's $3 for each haircut. This is her cost. And then she also made profit. She charged each customer $25 for each haircut. So it's 25 times X. And we want to know, when are these two things equal to each other? Because when it asks, when does it break even, that's when your cost and your profit are equal to each other. So here's how we would set this one up. We have our cost, we have our profit, and to figure out what X is, I'm going to subtract 3X from both sides. So 7,700 is going to equal 22X. And if I divide both sides by 22, we get the answer for number 16, which is that X is 350 haircuts. Let's move on to number 17. Number 17 says is a rectangle question. So we would start each one of these questions with a rectangle, as we did in class. It says the length of the rectangle is 4 more than twice the width. So if here's the width, the length is going to be 4 more than twice the width. Well, twice the width is 2W. 4 more than that is 2W plus 4, which means I'm going to have 2W plus 4 down here, and W is the same side as this side. So we have all of the sides there, and now it says that the perimeter is 50 inches. Well, to find the perimeter, you add up all the sides. So when I add up all 4 of these sides, I'll have 1, 2W, 3, 4, 5, 6W, plus 4 and plus 4 is plus 8, equals 50. And now I can solve this to figure out what the width is, what W is. I'll subtract 8 from both sides, so 6W is 42. And if we divide both sides by 6, the width of this rectangle is 7. And if the width is 7, I can go back up here and plug 7 in for this expression to find the length. 2 times 7 is 14, and 14 plus 4 is 18. So it's a 7 by 18 rectangle. Let's take a look at number 18. It says 3 consecutive odd integers. So I have 3 odd integers here, have a sum of 129. So if I let the first one be n, the next odd, if this is 15, 17, and 19, it could be 7, 9, and 11. But if I have the first odd integer, the next odd integer is going to be n plus 2. And the next one is going to be n plus 4. So if I add them together, I would get a total of 129. So now I'm going to simplify this. N plus n plus n is 3n, plus 2n plus 4 is plus 6, equals 129. Then I can subtract 6 from both sides, so 3n equals 123. And if I divide both sides by 3, n is equal to 41. That's the first one, which means the second one is going to be 41 plus 2, which is 43. And the third one is going to be 41 plus 4, which is 45. And so my 3 consecutive odd integers are 41, 43, and 45. And then number 19. 19, Greg and Ellen, this is a dirt problem. We have distance equals rate times time. Greg and Ellen leave Fort Wayne on their bikes traveling in opposite directions. So Greg goes one way, Ellen goes the other way. Greg rides at a rate that is 10 miles per hour faster than Ellen. So Greg is going a little bit faster than what Ellen is going. And after 5 hours, they're 200 miles apart. So after 5 hours, this distance is 200 miles. So we have Ellen's distance plus we have Greg's distance, which if you add them together, you get 200 miles. But we know that distance is rate times time. So that means Ellen's rate times time plus Greg's rate times his time is equal to 200. We're not sure what either one's rate are, but we know that if Ellen is going X miles per hour, Greg is going 10 miles per hour faster, X plus 10. If Ellen's going 20 miles per hour, Greg's going 30. If Ellen's going 15, Greg's going 25 miles per hour. It's always 10 miles per hour faster. Their time, they've both been gone for 5 hours. So Ellen's time is 5 hours. Greg's time is 5 hours. So we have Ellen's rate and times her time plus Greg's rate times his time together is 200 miles. And so now we can solve this equation. X times 5 is 5x plus, if I use the distributive property here, I'll get 5x plus 50 equals 200. 5x plus 5x is 10x plus 50 equals 200. If I subtract 50 from both sides, then 10x equals 150. And if I divide both sides by 10, then x is 15 miles per hour. Remember, that is how fast Ellen goes. And if Ellen goes 15 miles per hour, Greg goes 10 miles per hour faster, which means Greg's speed is 25 miles per hour. And that's how we would set up number 19. All of these questions are very similar to the types of questions you will see on your test on Thursday and Friday, or on Wednesday and Thursday. So I would go back and look over these questions. Ask me tomorrow if you get stuck on any of them, and then we'll review again tomorrow before we take our test on Wednesday.